Recording. All right, so we left off talking about validations, right? So I want to talk about email validations, bcrypt. So let me get to the platform here real fast and zoom in. That's way too small. All right, so we talked about basic form validations, pattern validation. So pattern validation is going to involve regular expressions. And my favorite quote about regular expressions, I think I mentioned this yesterday, when a developer says he has a problem and he says, I know I'm going to use regular expressions to solve this. And the saying is now he has two problems. So regex is, I'll just zoom in on this example of regex. What does this look like to you guys?
A mess.
A mess, right? That's how I feel. And so I'm not saying that regex is pointless or don't learn it. I'm saying I want you guys to focus on the essentials, focus on passing the belt exam. So we are going to import the RE is the regex module. We're going to copy this out of the file, paste it, and be done. Okay, so this is like, I can sort of start to tell you what's going on here. The caret sign means the front of the string. The dollar sign means the end of the string. A through Z, this means the first letter has to be a letter or a number. And that's about as far as I'm going to go. Plus means optional. But anyway, so we don't need to delve into this and practice regex or get too far into it. For now, just understand that the purpose of this line, right? RE is the regex module. It has a method called compile. We can pass this in, right? And then in our validator, which is right here, we can say if email regex, meaning this variable, this constant variable, matches what the user types in, meaning that it's validated, meaning that it meets the criteria set out in this string, right? This is basically a string saying these are the criteria we have to have for an email to be an email, right? And this is a simple one. These regex email validations can be pages long. So for our purposes, this is fine. Okay, so this is just saying it starts with a letter, it has this @ symbol, it ends with, it has a dot in there somewhere. So this is just validating that it's a somewhat, it's an email that looks like an email. People aren't just typing ASDF or your mom or whatever, right? They're typing out something that resembles an email, and that's good enough for us for these purposes. Okay, so this line just says if it doesn't match, we're going to shoot out a validation saying invalid email address. And for all validations, if it doesn't match our criteria, we change the Boolean value from true to false, and then we just return that variable. Okay, so when again, a function is what it returns, right? So if we say if validate user, right, and this turns out to be false, right? If this returns a false value, then that will be our validation. Okay, any questions about validations, email, regex, anything along these lines? Okay, let me just get a quick check. I need to do this more often. Just to show, just a hand symbol in the corner if you're following me. Cool, awesome. Awesome. Okay, so that's regex. That's as far as I want to talk about regex. The next thing I want to talk about is securing passwords. Okay, again, this is stuff I think that's good to know, but it's not like essential for the exam. So it's good information. I don't want to just gloss over it, but I don't want to spend too much time either. So who can tell me the difference between hashing and encryption?
Hashing just hides it, right? And then encryption actually encrypts it.
Okay, yeah. So hashing is one way, right? Once you hash something, you can't, well, theoretically, you can't use that hash to get back to what was passed in. So it's a function that's only goes one way. So if you pass something into a hashing function, it should return like this random string of numbers. Theoretically, there should be absolutely no way to go from that random group of numbers back to what the user typed in. Okay, so the encryption is sort of like a cipher, or like if you had like a decoder ring kind of thing when you were a kid. It's possible to encrypt a message, and with a key, right, with a key for the encryption, you can translate it back to the original message. So credit cards are an example of something that we encrypt, right? We don't want to send somebody's credit card information over the wire because somebody listening can write down the digits, right? So with a key, we can, the two people on either end of the encryption, as long as each one has the key, then they can read the encryption. So it's secure as long as it goes between the two people with a key, and nobody in the middle has a key, right? So if anybody gets a hold of the key, then they can encrypt the message. So the basic difference is encryption can be reversed, hashing cannot. Okay, does that make sense to everyone?
Yeah.
All right, so what we do is there's different hashing algorithms that have been used over the years. This is the example of what not to do. I think I've said this before, and I think you guys get the idea. We never, ever, ever store user passwords as plain text in our databases. Never, ever. Okay, because, and any personal data that we're storing in our databases should make the hair on the back of your neck stand up, right? You want to be very careful whenever you have anybody's data unencrypted, stored as plain text in a in a database. So we never do this, because if somebody hacks our database, then they have everybody's password and,
credit card information.
Right. So, well, they don't have the credit card information with their password, but they say passwords are like underwear, right? You change them often and don't show anybody you don't trust. But I don't do that. I use the same, I probably shouldn't say that, but I use the same password for everything, because you guys can probably surmise I have a horrible memory. So I use the same password. So if anybody stores my password, I'm in trouble, right? Because if somebody gets a hold of it, then they've got access to everything. So
Yeah, you could just go through all of those passwords and try all sorts of different bank accounts and stuff.
yeah, and that's what people do. They get passwords,
Yeah.
and they know that if you have a name and a password, then you can basically try all their financial institutions and gain access and do whatever.
Eventually it'll work.
Yeah.
So
So
bad.
we want to do use some sort of hashing algorithm to store the password. Okay, so it always goes out of my mind, and I need to write this stuff down. I forget that it's an MD5. There it is. MD5 is the old obsolete way to hash a password. So MD5 is obsolete because it's easy to break, right? I think any like moderately good hacker would be able to break MD5 and get into the passwords. It can't be reversed. Well, that's a lie. It can be reversed, right? So we want to basically make our passwords more secure. And the way we do that is by adding what's called salts. Okay, so some of the older versions of hashing algorithms used a salt, right? And a salt is just like if somebody's password is password, right? We add a salt to it, right? And that makes it more difficult or the hashing is more effective when the salt is added. But that isn't as effective as like we'll store. A more effective way is to give each individual user a separate salt, then use the salt and hash the password. But the way basically bcrypt is it uses the SHA-256, which is the hashing algorithm the federal government uses. I don't think anybody's cracked it yet, as far as I know. I don't know if Ed, if you know. I think it's still like pretty much impenetrable. And the way they make it impenetrable is the process that the hacker needs to go through to break it or to get the passwords or reverse it takes too long, right? So they basically use nested for loops to make the process of deciphering the password more difficult or take more time, right? So it would, if it's secure enough, it would take like, if it takes like 1,000 years or something like that for the fastest computer to try to break the cipher or the hashing algorithm, then it's more effective. So the whole point is just to slow hackers down. Okay, questions about that? Okay, so we use bcrypt. Bcrypt, I think, I've never used anything other than bcrypt. I think this is the industry standard. I know when I went through bootcamp, Rails had a version of bcrypt that we use. So bcrypt, I think, is pretty much the best. And the way bcrypt works is we need to install the flash bcrypt module, I guess. We need to, so when we first install, so if we already have a Flask application, we don't need to redo like reinstall Flask or reinstall PyMySQL. We can just run pipenv. As long as our shell is running, we run this command, and then we have access to bcrypt. Okay. So the way bcrypt works is bcrypt is well, based on this, what does it look like bcrypt is? What kind of data structure is it?
Object
It's not an object.
or class.
Class, very good. So we import the bcrypt class from the bcrypt Flask bcrypt module. And then it's pretty much the same syntax as when we create a Flask app, right? The only difference is we don't pass it under name. We actually pass it the app we're going to be using. Okay. So then we have this bcrypt object that we can then call methods on that will secure our passwords. So let me get my demo out. Okay, so I've created a application, and I've might need to, let me just do this just in case. So I'm going to say pip env. That's not going to hurt anything. I'll just run it. So pip env install, and you say Flask bcrypt. Okay, I know that's kind of small in the bottom corner. Can you see that okay? Let me move it up. And that's basically if we want to add bcrypt to a Flask app that's already existing, we can just run this and it'll install it. It's already installed, so it shouldn't do anything. So it'll show up in, why is that open? There we go. So it'll show up in our pip file as a separate package. So you'll know it's installed. And then if we do pip list, it'll confirm. And it looks like I need to start my virtual environment. Sorry. Pip env shell. There we go. Flask and bcrypt. Cool. All right. So just to give you an idea and sort of see bcrypt being used apart from an application. So I've made this just separate file in my Flask app called main.py because I couldn't think of a more creative name. And I'm importing from Flask app, I'm importing the bcrypt class, and I'm importing my app that's in Flask app here. So I basically have a Flask application here all set up. I've imported bcrypt here, and my app is right here. So I'm just basically importing these outside in main.py. Okay, so I'm going to print my app. So I'm just going to run this file. Oops. Yeah. So Python main. Okay, so I have my Flask app right here. So once I have my Flask app, I create the bcrypt object, and then I can call methods on that bcrypt object. Okay, so if you want to see what methods are available, there's the dir function, and the methods that are available are basically just these three. Okay, everything else is a dunder method. So we have check password hash, generate password hash, and the init app we don't use. We're just going to be using these two. This is a generate password hash and check password hash. Okay, so I'm going to call the first one, and I don't know why I keep using the word stinky. I apologize. It's my childhood nickname. So that's a joke. So I call bcrypt.generate password hash, and I pass it just a random string, right? So I'm
There
Oh,
he
there
is.
you go. Tyler's
Oh.
back.
Got him
Oh,
back.
my Wi-Fi was out all night last night.
Yeah, my
I'm
power.
totally
went out.
ready for have a good weekend.
There you go. You're back.
I have
Tyler.
no idea what happened. I apologize.
Did a little,
Did you
Did
guys?
all of our internets just go out at the same time?
must have been.
Did you guys get kicked off too?
Yeah, my Wi-Fi was going on and off the whole time.
Nah,
Yeah, it said
was
I
it
would-
said my internet is unstable. And
I
then
didn't
it
get
kicked me
kicked out.
I didn't get kicked out.
Yeah, I was good.
Okay, probably just me.
my shit's all fucked up.
All right.
Somebody
I
hacked our
apologize.
Zoom.
Russia.
Was anybody listening? What was I saying?
So you were talking about the two things that we could use in the like dir thing, the generate hash and this other thing.
Cool. Okay, let me. So it stopped the recording for me. So I was getting all excited because I was remembering. Okay, let me share my screen. Oops, and record. Oh, it's already. Is it recording? It is. Okay. All right. So sorry about that. So we have the bcrypt. Did you guys get the joke about my childhood nickname? Okay. I don't know if it was funny or not. All
I
right.
think
so
you were making the joke when I was kicked out.
Okay, all right. So you didn't miss much. So I'm going to call this, I'm going to set a variable called my hash, call the bcrypt generate password, and I'm going to pass it this string. Okay, and here I'm going to print what happens. So if I save this, run my file. Okay, I'm going to stop that dir thing. That's annoying. Okay, try it again. Clear this out so you guys can see. Run it again. Okay, so when I pass in a string to the generate password hash method, I get this. Okay, so I get this long, and the B represents binary, but that's not important. This is just the random, unintelligible string of numbers and letters, and I think there's some punctuation in there, that will basically be the hash of our password. Okay, so somebody comes in and they select the word stinky as their password. That generates, like we use this generate password hash method, and we store this in our database. So our database will only contain this. There is theoretically no way to go from this to stinky. Okay, and I'm regretting using this string, but there's no way to basically go from this to this. It's one way. The only thing we can do is use the other method on bcrypt, which is bcrypt check password hash. Okay, so if you lose your password or forget your password, generally what a website's going to do is ask you to generate another one, because they don't have your password. All they have is this, hopefully, and there's no way to get from this to your password. So when a user comes back, when a user comes to log in, what we do is when we first register them, right? So we register the user and we store this long string in our database. And then when they come back, we check it against the password they enter. Yeah, Tyrone.
So on like, you're saying that they would never like store your actual password, right? But like,
Hopefully.
I remember, so sometimes I like forget my password, but I'd be like close and I'd make a new password that was similar to the other one, and they'd be like, oh, sorry, that's the new password is too close to old password. Does that mean that they've like stored it like, or have like
That is a
plain text
very
version or
good
something?
question.
I think I was on like Facebook or something. I know they'd be keeping everything, but
Yeah. So, okay, so here's what I think is happening. They have a validation, right? Now, yeah, because they tell you that you can't use the last 3 passwords, right? What I'm thinking they do is they store the hash for the hopefully they store the hash for the 3 previous passwords and check your new password against those hashes. Does that make sense?
Yeah, but
So it would have to be the exact same then though, right?
Well, so let me show you how this works and maybe hopefully it'll make more sense. So when they come back, right, I have my hash stored and my hash is equal to this long string, right? So if they come back and they enter the password that they entered initially, this check password is going to compare the hash that's stored in the database to the string that they entered when we prompt them for their password.
so it's not randomly generated then. It's generated
Oh,
by
yeah, it's
some
not random.
algorithm.
No,
Yeah.
it's not random at all. Bcrypt has an algorithm, and that I'm assuming is a closely guarded secret as to how it actually works. But they run it through this hashing algorithm and generate a long string. I don't know how many, I think this is like, I forget how long it is, but this hash we retrieve from our database, compare it, right, with using this check password hash method, and this will return a Boolean, right? So if they match, if this hash is returned from this string, then it will return true. So Tyre, I think what they're probably doing is storing the last 3 passwords you enter, storing the hash, and then running each through this method. And if any of them come back true, they'll say you can't use the same password. Because they don't say you used, Handsome 69 before, right? They say you can't use one of the previous 3 passwords, right?
Yeah.
And I was just assuming your
makes
password is
sense.
Handsome 69.
Of
So,
course.
so let me show you how this works. So when I run this and I print check, or I almost said console log, print check. So these match, right? So when I run this, I run Python Flask and I get true. Okay. You'll notice that a different hash is generated. These 2 don't match. You guys see that? So the algorithm is smart enough to be able to go from whatever hash is generated to the string that was initially entered. Okay.
Wait, so is it differently generated every time? You're saying, or will
Yeah,
those 2 always
yeah.
be the same?
No, so this is in no way indicates what the password is, right? So it's not going to generate a unique value every time. But each of these, if I were to plug it into my hash, and let me do this so I can show you. And hopefully it works. Okay, so I'm going to make hash 1 and I'm going to generate a hash for each one. So I'm going to print my hash and my hash 1. Okay, so I'm going to run this with my fingers crossed that I'm not going to look stupid. Okay, so it generates the 2 hashes. Now and it runs true. So if I put in hash 1, it should return true. And it does. Okay, so it doesn't matter, like it's generating a new hash every time, but the algorithm, and I don't know how it works, right? But it's able to go from the hash that was generated to the original hash. I'm sorry, to the original password. So Tyre, I think what they're doing, like if you say Handsome 69, I spell Handsome right? That doesn't matter. So this Handsome 69 is going to be run through the hashing method, right? And it's going to generate a new hash, right? So now my hash is the hash for Stinky, and my hash 1 is the hash for Handsome 69. So now notice that the Boolean value is false. And that just kind of worked out for me. So I'll explain it again if that doesn't make sense. Does everybody understand where I'm going, what I'm saying?
It was false because you put the wrong key in.
Yeah.
My hash 1 for
Right. So
Stinky.
your password is now hash 1, right? So I
Yeah.
tried to compare the hash for Handsome 69 with the password Stinky, and it returned false because it's the wrong hash. Does that make sense?
Yeah.
Okay, so basically when you go and you say, I think like retrieving a password, I don't think you can retrieve a password anymore, right? So you need to basically in my experience, every time I lose my password, they make me make a new one. So if they say this on the platform, if you ask for your forgotten password and they send you the password, don't run away from them, because you never ever ever store plain text passwords. Tyree, does that answer your question? You
That
stuck
does.
around.
Thank you.
Okay, cool. All right, so that's going to be a real short video, but I'm going to stop it anyway because I'm remembering.
Is
I
that a
wasn't even
tip to
recording.
avoid?
Was I recording?